Hi everyone. In this lesson, we're going to learn how to take a mathematical sentence or a mathematical equation in word form and translate it into mathematical form. So let's get started. All right, number one, 5 more than a number is 12. Okay, we know this is going to be an equation because we have the word is. Is gives us the equal sign. So anytime we read the word is in a mathematical sentence, we are given the equal sign. 5 more, we know that means we have to add. We have to add something to something that's already there. So if we read on, we'll find out what's already there. So we're going to add 5 more than a number. So we have this number, but we're not given exactly what the value of that number is. So we're just going to go ahead and represent that number with X. So we have some number, some unknown number, we're going to use X to represent. And to that, we're adding 5 more. And we know we're writing an equation because we have the word is means equal to. So it's going to be equal to 12. So we went from word form to mathematical form. All right, let's go on to number 2. 8 less. So we know we're going to be subtracting. We're going to be subtracting from something that's already there. So let's read on, see what we already have. 8 less than a number. So we have some number. We don't know what that number is. So we'll represent that with X also. And from that, we're going to subtract 8. We know is means equal to. Equals 40. That's it. Again, so we took it from word form and put that sentence in mathematical form. Let's keep going. 3 times a number plus 3 equals 33. So if we take some number and we multiply it by 3, that's what that means, 3 times a number. So that's what we have, 3 times a number plus 3, add 3, that will be equal to 33. We're not solving these equations, we're just going to write them out. All right, let's keep going. 6 times a number, that's 6x. You could use any letter that you want. I'm using X, you can use N, you can use Y, you can use M, you can use any letter that you choose. 6x is, so we need an equal sign, is 24. That's it. Some are easier than others. The product of a number, you need to know the word product means multiply. The product of a number and 7, so here what we have is 7x. These two are being multiplied. Product means you're multiplying. Okay, what are we multiplying? A number and 7. So the product of a number and 7 gives us 7x. To that, we're going to add 20 plus 20. And is will give us the equal sign, and that'll be equal 34. The product of a number and 3, so this is our multiplication right here. Product of a number and 3, I'm sorry, -3, so it's going to be -3x. We don't know what the number is, so we're going to represent that with x. And this number x and -3 are being multiplied. Okay? And that's going to equal to, because we know we have the word is, which means equal to, -15. Number 7, 4 more. So we're going to add 4 more to what we already have. Let's see what we already have. 4 more than the product of a number and 12. So we have a product here. We have 12x. The number, we don't know what that is. So that's going to be x. So we have 12x from here. The product of a number and 12. That gives us 12x. And to that, we're going to add 4 more. And that is going to be equal to 40. All right, number 8, 15 more than the quotient of a number and 2. This expression right here gives us the fraction. Quotient is actually the result when you take a fraction. So quotient of a number We don't know what that number is, so we're going to use x. It's a quotient, so we're going to have to write a fraction. So x over 2 will give us this part right here, a quotient of a number and 2, which will give us that fraction. And then to that, we're going to add 15 more, and all that will be equal to 60. All right, number 9, 6 more than the quotient of a number and 10. So we're going to add 6 more to what we already have right here, the quotient of a number and 10. We don't know what that number is, so our numerator is just going to be x, our denominator is going to be 10. When you have an expression like that, you are going to be writing a fraction, and whatever appears first will be your numerator, whatever appears second will be your denominator. Okay, now to that, I'm going to add 6 more, and that's going to be equal to, because we have the word is, it's equal to 86. Okay, you should know the word sum means you're adding. Okay, so the sum of a number and 5, that means we're going to take some number and add 5 to it. Okay, that would give us the sum of that number and 5. So this expression right here, the sum of a number and 5, is expressed this way. The number, we don't know what that number is. We're using x again, and to that we're adding 5. And that will be equal to 30. Number 11 is just like number 10, the sum of a number and 52. So whatever that number is, we're just going to use x. And to that, we're adding 52. How do I know I'm adding? Because they want me to take the sum of this expression right here, a number and 52. Okay, and that's going to be equal to 80. Now difference means we're going to subtract. Okay, so let's see what we're subtracting. The difference between a number and 12. So we're subtracting these two. Okay, a number, we'll let that be x, minus 12. How did I know to subtract these two here? From this word right here. I want to take the difference between these two, which means subtract. And all that is going to be equal to 48. The difference between a number and 40, so I'm subtracting these right here. X minus 40, and all that is equal to 120. Okay, this one you have to be careful. Twice the sum of a number and 3. Well, I'm going to focus right here. I want to go ahead and write the sum of a number and 3. So that would be x plus 3. Now, what am I going to do to this sum? What am I going to do to this sum? I want to take twice that amount. In order to do that, I need to put this total right here in parentheses. And then I'm going to multiply it by 2 in order to take the sum of x plus 3. And then all that will be equal to 18. Go ahead and pause the video and try number 15. It's just like 14. So I'm going to go ahead and start with this part, the sum of a number and 5. So x plus 5. And what am I doing with this sum? I want to take twice that amount. So I'm going to need parentheses to show that I'm taking twice that whole total. And that will be equal to 200. Twice the difference between a number and 8. I'm going to start right here. I'm going to take the difference between the number and 8. So take their difference, and what am I going to do with that difference? I'm going to do one more thing. I'm going to take twice that amount. Okay, so I knew that I have to subtract these two, and then come back here. I know that I have to, whatever this total is that's inside the parentheses, I got to take twice that much. And this will be equal to 20. Twice the difference between a number and 14. So let me write the subtraction problem right here first. A number and 14. So that's going to be x minus 14. And what do I want to do with that? I come back here and it tells me what to do with that. Take twice that amount. So I need parentheses to show I'm going to take twice that amount. And that will be equal to 48. All right, the sum of a number p and 7. So they're telling me that I need to add the number p and 7. So we'll take p and we'll add 7. So we're taking their sum. That's how I knew to add this part, because they told me that I want the sum of that. And then that is divided by 12. So we'll take that and divide it by 12. And then the result, that means equal to, the result is 3. That's it. So you'd have this equation. All right, number 19. 16 is divided by the sum of a number q and 1. So we're going to start with 16, and we're going to divide that by this sum right here, number q, the number q, and 1. It's a sum, so we have to use addition sign here. So that's what that says. The result, that means it's equal to, the result is 4. And we're going to skip this part for this lesson, just writing the equation. A number x is subtracted from 7. Okay, so x is being subtracted. If you read carefully, x is being subtracted from 7. So you start with 7, subtract x. See, a number x is subtracted from 7. When the result is divided, so when we divide this by 3, then the quotient, the result will be 2. Okay, when the way the word quotient used in this context, that means when you take this fraction here that you have on the left side, the result will be 2. Because the quotient is the result of dividing a fraction. All right, number 21, 12 and 7/10 more. So I need to add 12 and 7/10. I need to add that to something that's already there. Let's see what's already there. 5 times a number d. Okay, so we take 5 times the number d and add to that 12 and 7/10. So that would be 12.7. And that would be equal to 15 and 3/10. 15 and 3/10. And that would be this equation. All right, so number 22. In this case here, you're given the word problem, and they're asking you, how would you write it? Which equation would be correct, A, B, or C? So let's read the problem first. Claire bought 8 tickets for a total of $104. So she bought 8 tickets, and the cost for the whole total was $104. She had a coupon code to get $3 off of each ticket. So each ticket she bought, she's saving $3. Let X be the original price of the ticket. All right, so the price of the ticket is X dollars. But remember, she's saving $3 off of each ticket. So we're going to subtract from the cost of each ticket $3 because of the coupon that she has. Okay? So this is going to be the cost of the ticket. Cost of each ticket. But is she buying one ticket or multiple? Remember here, she's buying 8. So the cost of one ticket is X minus 3, but we want to buy 8 tickets. So we're going to go ahead and put this in parentheses and show we're going to buy 8 tickets, because each ticket will cost us X minus 3. We want 8 of those. And the total is going to be 104. That's given. So we just need to see which one matches. And if you look carefully, you will find that the answer is C. Okay, we have exactly what C has stated. All right, let's go on to number 23. Claire buys a hat that's 60% off and socks that are reduced to $5.49. She spent a total of $9.49. So she buys a hat. She buys a hat. Plus she buys socks. and the entire total is $9.49. So we just need to write what that looks like mathematically. Now let's think about this. Usually, if there's no sale, you have to pay 100% of the cost. But she is saving, Claire buys a hat that is 60% off. She's saving 60% off. She really doesn't have to pay 100% of the price because they're taking off 60%. So that means she's only going to pay 40% of the cost of that hat. Now, if you take 40% and you change that to a decimal, you're going to have to do this. Move the decimal point 2 places to the left, and that's going to give you 0.4. Okay, so she's going to pay 40% for the hat. Okay, so we'll represent the cost, whatever that cost is. We know we're going to only pay 40% of whatever that cost is. We'll represent that with X. So we're going to have to pay 40% the cost of the hat, whatever that is, plus we have to pay $5.49 for the socks, and her total came out to be $9.49. So we just have to match our equation with one of the ones that are given. All right, so it looks like B. We have this, we have that, we have the same thing. Okay, let's go to 24. Miriam babysat 11 hours this week. So this week she babysat 11 hours. That is 5 fewer hours than 2/3 as many hours as she babysat last week. So basically they're comparing the number of hours she babysat this week to the number of hours she babysat last week. We know this week she did 11 hours, okay? And they're relating the two, her 2 work hours this way. So this week, her total 11 hours, that's the same thing. That's what they mean. That's the same thing as 5 fewer, fewer means subtract, 5 fewer than 2/3 as many hours as she babysat last week. Well, 2/3 of the whole total amount. I don't know what the total amount is. I don't know how many hours she babysat last week. But I can do this, 2/3 of her total hours, I can just represent that with X. So 2/3 of all of her hours, X hours that she babysat, minus 5 equals 11 hours, okay, which she babysat this week. Now, if I solve this equation, I will be able to find out how many hours exactly she babysat last week. Okay, but we're actually not going to solve this equation. In this lesson, we were just focused on writing the equation. And this concludes this lesson on translating word problems into equations.